photo backside. Okay. Okay. So welcome to the second session of exponents and logarithms of 11th standard of Australian curriculum. So I'm sharing my screen here, which is my screen. Yes. Sure. So now I enable my camera to here. So I'm sharing my screen. If I enable here, then the live session will not take the camera. Okay. So let me share my full screen. I think I can. No need if it is like this. I shared my side screen only one window. So no need of camera enable now. So I'm saying that this is a photo which is 2 years back. I think it's still same costume I'm on. Okay. So here I'm minimizing. So there is other access of camera will be closed. And now here we are and we are live. Okay. So I'm making minimize. Okay, so this is our last class. I stopped here. Okay, so the development model of problems, which is specify these powers by first taking the reciprocal as indicated by the negative index. First of all, we have to reduce. We have to remove the negative index. How the A will be converted into? How can we remove the negative index? Yes, 25 power minus 1 by 2. How can it will be reduced to simple positive power? No, no, no. Minus square root is only positive. Minus means it's get down. Okay. So 25 power minus 1 by 2 is equals to 1 by 2 power 1 by 2. 25 power 1 by 2. It is minus 1 by 2. So the minus will be reduced by 1 by 25 power 1 by 2. And it is positive. Now it is square root 25 and then it will be 1 by 5. So it's simple. Even B is simple. Even C is simple. Even D is simple. But E, F, G, I want to go with G. So what is G? G is, it's a minus. How can I write in the first step? 3 by 4. Okay. So after this, in order to simplify, we have to take the denominator. So what is the denominator? We can write it is fourth root of 81 power 3. Is it clear? A power 1 by n is equals to nth root of a. And it is nth root. 81 can be written as 1 by, it is 81 power 1 by 4. It is same power 1 by 4, but we can write it as uh, it is fourth root of 3 power 4. 3 3 is 9 3 is 27 3 is 81 and power cube as it is. So now this 4 and this 4 get cancelled, becomes it will be 1 by 4. It is 3 power 4 by 4 power 3. So it is 1 by 3 power 3. So it is 1 by 27. Okay. Nothing is there. Basically, there are 3 to 4 formulas are there. We have to manipulate it properly. Negative becomes get down to denominator wherever. If it is in the negative in the denominator, it will come to the numerator with positive sign. Okay. And if it is the base is reciprocal, base is the fraction or a by b form, then we have to take its reciprocal. This is about a to g of 10th problem. And now how can we do this? These are the examples. So it is 1 by 16. So this can be written as reciprocal of 1 by 16. It is 16 power 1 by 4. And 16 is nothing but 2 power 4 and whole power 1 by 4. It becomes 2. Clear? And it is 49. The reciprocal means 49 by 1, 49 power 1 by 2. It will be 7. 7 square is 49, 2 to get cancelled. But the situation about this problem, so this becomes, it is 8 by 27, 125 whole power 2 by 3. Okay. So then this 3 comes to here. It is cube root of 8 by 125 whole power 2. And cube root, it goes to numerator and denominator. It is cube root of 2 cube by cube root of 5 cube whole power 2. So it is cube root of 2 cube will be 2 by 5 whole power 2. It will be 4 by 25. Okay. So you need to do practice. Without practice, this basic numerical problems will not solve simply. It goes to okay. And here we have to simplify it. It is a product. Please be careful. Product rule is there. 3 power 1, 3 power 1. It is 3 power 2. X power 1 by 2 plus 1 by 2. It is x power 1. Y power 1 plus 2. It is y power 3. Okay. So simply we can add 9xy cube. Is it clear? And next it is x square y cube by, and by it is, you can write it as x square y cube by x power 1 by 2 y power 1 by 2. So power goes to the numerator, become minus sign. It is x power 2 minus 1 by 2 into y power 3 minus 1 by 2, which is x power 3 by 2, and y power 3 is the 6 minus 1 is the 5 by 2. Clear? So now I suggest to do yourself one problem. Can you do C? Do it on a pen paper. Take a pen paper and do it. C and E. Do it and share the solution. C and E. Simply, if numericals are there, then cancel it. In the product rule, when bases are same, powers to be added. And in the division rule, when bases are same, powers to be subtracted from the numerator by the denominator's power. Can you do? Okay, good. Thank you. Okay, I'm live. Okay, got it. Oh, 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 oh. You did some mistake. Okay, I'm coming to screen. I'm coming to screen. I'm taking your solution. You did some mistake. Please concentrate. Concentrate. Okay. It is, I think it is A. It is not 0. And you have to remember the formula. So here, C. It is okay. S power 2 by 2 minus 1 by 2. No, 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 no. It's a power 2 or 1 by 2. Okay, it's 2. It's 2. It's 2. 2.5 minus 2. It's a half. Okay, good, good. What about this? It is okay, okay. Right, 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 right. I thought that you made it. This is the answer. Good, good. Both are good. Both are right. Both are right. It is simplified. So I think you can do the rest all problems also. Okay. I will try to do one more problem here. I. So if you see the I. So what is the I? It is x power 3 by 4 power 4 into x power 4 by 3 power 3. So what is the power of power formula? It will be x power 3 by 4 into 4 into x power 4 by 3 into 3. 4 4 get cancel, 3 3 get cancel. X power 3 into x power 4. Bases are same, powers to be added. X power 7 is the answer. Okay, so this is the I. So if you understand basic logic or basic formulas, then you can do everything. It is simple way. Okay, it is not a tough mathematics. Rewrite the expressions using fractions and negative powers. So we need fractions and negatives. This can be written as 1 by x power 1 by 2, and when it goes to the numerator, x power minus 1 by 2. It is 12 into x power minus 1 by 2. No role of coefficient, minus 5 into x power minus 1 by 2. So 15 into x power minus 1 by 3, because it is a cube root. If nothing is there, by default it is 2. So you can do it. It is 5 by, it is x power 1 plus 1 by 2, which is 3 by 2. It is a 5 into x power minus 3 by 2 is the required answer. And here it is x power 8 into x power 2 plus 1 by 2. X power 2 plus 1 by 2, it's a 2.5, it's a 5 by 2. It is, but when it comes to down, then it will become minus 5 by 2. He said to write with the negative powers. So that's why in the denominator. So similarly, we can simplify and provide the answer. It is 16 power 1 by 2 plus 25 power 1 by 2. It is a 4 square. It is the 4 plus 5 square. It is 5. This is equals to 9. Okay. So similarly, you have it is 2 square. 2 power 4 whole power 1 by 4 minus 5. It's a 25 power 1 by 2. It is a 2 minus 5 will be minus 3. So basic manipulations only. So nothing else than that. The 15.1, the cost of installing a standard swimming pool is rising exponentially according to the formula. $66,000 into 1.03 power n, where n is the number of years after 1st January 2015. Okay. So what is the original cost? So what is the original cost? So there is installation charges. Okay. So it grows for every year, but in the beginning, n value must be 0. Okay. So that is C is equals to $6,000 into 1.03 power 0, and its value is 1. This becomes $6,000. Next is the 1 year. After 1 year means n is equals to number of years it is. It's a 1 year completion, means this is C is equals to $6,000 into 1.03. So you have to product to get the answer. Use your calculator to find correct nearest to $10 the cost of installing pool in these dates. So this is after 5 years. Okay. So this is half of the year. N is equals to 1 by 2. It is after 3.5 years. N is equals to 3 1 by 2. Is it clear? So now this is the problem 15. The 16. It's a cap. We call this symbol as cap. Cap. It is a cap. So use the button labeled exposure cap uh, on your calculator to approximate these powers. You have to use calculator to find out these values. 7 power 8. So in the calculators, what happens? In the calculators, what happens? So there is exit 7 to the power of 8 you need. Okay. If you need 7 to the power of 8, I'm opening the calculator. So for that I have to share. I'll try to share. Here it is. Here it is. I should share it is with another. Just give me 1 second. I have to share the full screen. I shared your full screen, but my live session will stop my screen sharing. So I'm getting back to my window sharing of this live session. The calculator. It is 7 to the power, where it's a y power measure. 7 to the power of 8. No, it's wrong. 7 to the power of n. There must be some x to the power of y. Here it is not. This calculator is a different one. I'm just opening the scientific calculator. Desmos. So this is 7 power 8 we can do in the calculator. Is it clear? So it is 5764801. And the next question is 5 power 2 by 3. So first of all, write down 565. But you know, so you have to open, come to the fraction power, which is divided by 5 and close the parenthesis. So you will get the answer, which is equals to, okay. So this is a way of writing the values. 565 power 2 by 5. It is 12.61 something. Okay, 12.61. I'm getting back to here. Okay, so this is the notation, scientific calculator. Okay, express your answer in scientific notation. Can you see 565 power 2 by 5 is written as by the scientific calculator is 12.61302581. Okay, it is. So this is a calculator. I'm sharing it here. See what is the number here? It is 12.61302865. 12.6130 2856. 12.61302856. 12.61302856. But this is not the scientific notation. The scientific notation, the left hand side of the digit will be 0 to 9 only. So it will be 1.61302856 into 10 to the power of 10 into 10 into 1.26 into 10. So this is a scientific notation. And similarly, you can to the power, not here. So to the power minus square root 7. Is it clear? Square root 7 whole is minus root 7. It is 0.06214986338. Okay. To use the scientific calculator, that is also important. And you can use this pi notation. You can see the pi notation on the calculator. There is a pi. Okay. There is a pi. Pi symbol is also there. Oh, these will be available in the scientific calculators, not in the general calculator. Okay. So now you have to expand, use the formula to expand the formula a square plus b square minus plus 2ab a square plus b square minus 2ab and all. Here it is 18 power x. It is 3 power 4 whole power x. It is 3 power 4x. 1 by 3 power minus 4x. That is equals to 1. So minus 4x is equals to 1 implies x is equals to minus 1 by 3. So this is a way of getting number. So similarly, you can simplify all this. And this 19th one, it is important. Can you read up the answer? Question. Can you read up the question? So here the question is different with the different powers. How can we compare which one is bigger, which one is smaller? So that is a different logic. That is a different logic here. We have to apply the question with a different questionnaire. So I'm taking the image. Why he said sixth power? No, that is the LCM of 6 and 2, 3 and 2. Okay, so here it is 11 power 1 by 3. Take whole power 6 and whole power 6. What happens? The reciprocal in the power will be dilute. The denominator in the power will be dilute. It is 11 power 6 by 3 less than 5 power 6 by 2. So now you can cancel 3. That's the least common. It is multiplied by all. Okay, power 3. So it is 11 square, which is less than 5 cube. It is 121 is less than 125. Clear? Similarly, what we have to do for B? We have to raise up to what? 10. Right, very good. It's power 10. Make it to 10. It is 2 power 5, which is 32. It is 5 power 2, which is 25. So this will become, this is the case. Okay. Similarly, so this you can do for the 15 to the raised to the power 15, and it's 20. So 20 could be, it's a 4, 5 are 20. There are two factors. It is 7 power 3 by 2. Okay. It is and 20. So what we have to do? That there is no denominator. It is 1 by 1. Their LCM is 2. Raised to 2 power 2 and power 2. It will be power 3. It will be 20 power 2. 7 7 that 49, which will be 343, and 20 square will be 400. So it is less than, which is C. Clear? Try to understand. I'm not doing very deep mathematics. I'm doing this basic maths only, but you have to understand the logic. Okay. So 19 is done. So that's it. Functions. Okay. So it is up to. Is it clear? What is? I will ask some questions here. So please answer to my questions. 5 power 3, 5 power 7. How can I write? 3 plus 7. So 5 power 3 plus 7. So 5 power 10. Next one. 2 power 92 by 2 power 32. What is the answer? 2 power 92 minus 32 equal to 2 power 60. If you want to note this number in the negative power, it will be 1 upon 2 power minus 60. Okay. And next 3 by 2 whole power minus 5. How can you do this? How can you do this? Ha 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 ha. You continue. Minus is there. The base reciprocal becomes reciprocal is 2 by 3 whole power 5. It is 2 power 5 by 3 power 5. Clear? So this is a query of exponents and all. So now, so now, it is 7c. Logarithms, I said it is from the exponents only. Okay, it is from the exponents. Logarithm is from the exponents only. Okay. Uh, just give me 1 second. So the logarithms, 7c is the logarithms. The introduction to this chapter mentioned that would be growing on cheese was doubling every day. It's some example he's doing. Okay. So here we use logarithm means see 8 is equals to 2 cube. It is same as logarithm of 8 with base 2 is equals to 3. This is the main conversion between exponential and logarithm. Okay. If I write n is equals to a power x. If you're writing n is equals to a power x, so which implies that x is equals to log n base a. Conversion, reverse conversion is also same. So that's why here we call a as base only. That's why we call here a as base only. Is it clear? Because here it is a base. That's why here log n base a. It is log n base a only. So if n is equals to a power x, if n is equals to a power x, so then it is x is equals to log n base a. Is it clear? For example, this is 8 is equals to 2 cube. Okay. So I am taking 16. How can we write 16 or 27? How can we write 27? 3 power 3. And you can write it as n3. 3 is equal to log 27 is 3. Log 27. That's why I write here. Okay. For example, 125 is equals to 5 cube. Okay. 125 is equals to 5 cube. What happens? It is 3 is equals to log 125 base 5. Is it clear? You have to understand this. Mainly this is the equation. But the mhm, mhm, NSA. Now you have to remember whatever the technique you may follow yourself. Try to remember these both are same. They both are same. They both are same. And one work as inverse to the other one. Logarithm is inverse of exponential. Exponential is inverse of logarithm. Both are same. Okay. So, but here the restriction a should not be negative. Okay. A should and n should always positive. That is 0 less than n less than infinite. Okay. And a is also 0 less than a less than infinite. Moreover, additional condition a should not equals to 1. This is a major condition. Okay. So now we are going to formal definition of x. Can you see? So log y is equals to log x base a. It's the base a. See, can you read this definition? That's it. X base a. Okay, it is y is equals to log x base a. Okay, it is simply y is equals to log x base a, both the same as x is equals to 8. A is positive. So here x is always positive. By default, he took x is always positive. A is must also be positive, and a should not equals to 1. Okay, so in log x base a, so this is 0 less than x less than infinite, this is 0 less than x less than a less than infinite, and a should, we can give number of results by observing the numbers here. i will tell you I will tell you log x base a na? So there is a table, x values and y values. If x lies between 0 less than x values and a values, okay, x values and a values restriction, okay, it is 0 less than x less than 1, so the sign is negative. 1 less than x less than infinite, the sign is positive. 0 less than a less than 1, the sign is negative. 1 less than a less than infinite, the sign is positive. So now we can tell log 2 base 3, is it positive or negative? Because 2 falls in this slot for positive positive. I will take one more. Log 0.5 base 200. Negative. That's it. This is the key. It's the most important bit. It's the most important. It's an IIT bit. No one, see, until calculation, we can't say any value. But here log 0.5. 0.5 means it's a negative sign, not value, negative. It's a negative. And the base value is a positive. Negative and positive will be negative. Okay, it's negative. And we have many applications are there while watching numbers. You can even log base 2 base 3. One is odd, one is even, then it is a rational number. If one is odd, one is even, then it is a rational number. Okay, so those kind of applications are there by observing the numbers in the base and the value. Okay, it is same. It is same. The log is the index, has index in case 3. The log is index. The log is the index. Okay, so this is the notation only. Okay, examine the sentence that notice that the base of the log is the base of the power. Base of the log is the base of the power. The log is the index. This value log is the index. Okay, 3 is the index of this power. So here you can convert. It is 10 power 3 is equal to 1000. So therefore it is log 1000 base 10 is equals to 3. So log 81 base 3 is equals to 4. Okay, a little bit conversion only. Whenever you write, it is log base. Base is clearly mentioning the base. Okay. In generally, we might not clearly mention. Sometimes we used to write log. Sometimes we used to write n. Sometimes we used to write log base 2. So here you mentioned base 2. So clear. It is no issue with the mentioning the base value. What happens when we don't write any base? So ln means base e, log means base 10. Ln means e, log means base 10. By default, no need to write again and again. Mathematicians are lazy people. They don't write the repeated symbols. Okay. Actually, repeated, even in the professional English also, you're repeating words. You're repeating this same language. Means your quality of language is getting down. Okay. So in mathematics, repeating the same symbol 100 times, it's a waste of time. Okay. So now finding the logarithms, you can understand it is easily. So what happens here? It is 32 is equals to 2 power 5. So how can we write it? Okay. So 5 is equals to log 32 base 5. Is it clear? 32 is equals to 2 power 5. So 5 is equals to log 32 base 2 base 2 base 2. Therefore x is equals to 5. The value of this logarithm is 5. Okay. And moreover, see here, log k base k is equals to 1. The properties will come in the soon. Okay. Log k base k is 1. If base value and the value of the domain is same, then its value is 1. And log x power n base a is equals to n into comes to front. Then also you can simplify. For example, 6 and base 6, base 10. So the power is there. It comes to the 6 into log 10 base 10. When the log and base both values are same, it will be 1 equals to 6. The answer is 6. So there are several other techniques also there in order to simplify the logarithms and exponents. Okay. So the negative fractions. Okay. So negative fractions. And log is never defined on the negative values. Log is defined on the positive values only. Log is defined on positive values only. Okay. So solve each logarithmic equation changing into index equation. Okay. So what is there? Can you explain the A? Now you have to explain. I am the student, you are the teacher. Very good. Mm-hmm. How it is -1. Okay, we have to get it down. Uh, so it is very good. It's a 1 over 7 is there. It's 7 power x is there. So we have to send the 7 power x to down. So it is 1 over 7 power minus x. Okay. And here it is 1, here it is minus x. So that's why 1 is equals to minus x. So implies x is equals to -1. Okay. So similarly here it is again. So 1 upon 3 is equals to log 8, log x base 8. So when you write it down, it goes to x is equals to 8 power 1 by 3. Okay. And 1 by 3 is nothing but cube root of 8, or you can write it directly, it's a 1 by 3, and 2 is nothing but 2 cube power 1 by 3, and 3 get cancelled, it becomes 2. That's also direct way to write the answer. Okay. So these are the basic powers and all. Logarithms on the calculator. So now you have to use the calculator. So please, now you have to read up these two para. Please read up this first para. I said that simply log means it's log base 10. If you want to work with log base E, then we have to look up in the chapter 9. Okay, so that's why I came to start this chapter 7. If you want to go with the chapter 9, I said that base, all these things will come here. Okay, So the function 10 power x is usually same key as log. So these are the same. Okay. And is accessed pressing shift allowed by log. And these two are 10 power x or log. Both are same inverse to each other. So I said that these are inverse to each other. Exponents and logs are inverse to each other, or no? From the beginning case onwards, I'm telling they're composite inverse functions, composite inverse function. And the operation of 10 power x we can learn later. But right now, how to evaluate the logarithm with different bases. And most of calculators allows only log base 10, which is simple log, and log base e, which is ln. Okay, ln means natural logarithm. Can you see, is there any ln? There is no ln. Okay, so it is a square a power, there is no ln. So what is this scientific calculator? It is not the scientific calculator, it's functionals. So how can you see this symbol? ln. Natural logarithm means log base e. It is simple log. It is log base 10. Okay. If you evaluate log 10, what will be the value of log 10? It's 1. Because base 10, log 10, base 10. But if you take log, if you take ln, if you take ln 10, it is not 1. It is log 10 base e. Okay. So it is different value. It is different value. So it is different. Okay. I'm getting back to the main function here. So this is a way of understanding using scientific calculator. Now getting back. So it is an example locating the logarithm between two integers. So it will be the same. It is a simple application. We can get it down. So locating logarithm between two integers. How can we identify? See, if you have the calculator, simple calculator, it is a problem. If you have scientific calculator, you don't have any problem. You can do that. But most of time, we don't have the scientific calculator. Okay. Most of time we will have only simple calculator, and how can we do manage the logarithm functions in mathematical evaluations? Okay, so in that case, so this will be helpful, locating logarithm between two integers. So we might not do exact value, but we might give the answer on an average answer, okay, in between 3 and 4. So can you see, use the list of powers of 2, explain why log 10 base 2 is between 3 and 4. Okay, so I'll tell you. So it is 2 power 3 is equals to 8, 2 power 4 is equals to 16, or this lies between, there is a 10 or no? This is 8 and 16. In the 8 and 16, is there any value between 8 and 16? 10 value is there. And see, the base is 2 only he took. So this is the same base. Okay, if the base is different, we have to take different. 2 cube is equals to 8. 2 power 4 is equals to 16. So in between there is 10. Okay. So if you apply to logarithm to both, all three sides. Okay. If you apply to logarithm to all three sides, it is log 2 power 3 less than log 10 less than log 2 power 4. Its value is 3. 2 power 3 base 2, base 2, base 2. So log 2 power 3 base 2 is nothing but 3, less than, it is log 10 base 2 is less than 4. So here in this way we can show that this value of logarithm 10 base 2 lies between 3 and 4. And the technical. So whenever it is a technical, it is quite important. We have to use beyond the example notations and all. Okay. So here I would like to give a 10 minutes break. Okay. Hello. Okay. I will set 2:03 in my time IST. So we'll back at 2:15. Okay. The class will go up to 3:15. Okay. So here I would like to give a break to my online session.